In this video, I'm going to uh, prove two useful results when you're solving quadratic equation. So let's read this question. It says like this: find the value of k if the roots of this equation, which is 2x squared plus minus 12x, 2x squared minus 12x plus k plus 2 equal to 0, are of the form alpha and alpha plus 2. That is, there is a difference of 2 between the roots. So if one root is alpha, so what they're saying is x1 is alpha, x2 is alpha plus 2. So that's the difference of 2. So there are two formulas which I want to discuss. So this is the formula: sum of roots of any quadratic equation. This is a good formula to remember, those who are learning algebra. Sum of roots in a quadratic equation, we're talking about x1 plus x2 is minus b over a. Okay, I'll prove this. And the product of roots, if you multiply any roots, product of roots, this is sum of roots, product of roots is x1 times x2, dot means times, is c over a. So this is a good formula to remember, but this can be proved very easily. So let us prove this. Okay, so let us prove these two equations, or these two formulas. So the quadratic formula is x is minus b plus or minus square root of b squared minus 4ac over 2a. So if you want to write this in two forms, I can say x1, I hope you understand, this is minus b over 2a plus square root of b squared minus 4ac over 2a, and x2 I can say is the same thing but with a minus b over 2a minus square root of b squared minus 4ac over 2a. Okay, so what happens if I add them? This is the general form. So if I add them, x1 plus x2, you don't need to add the whole thing. If you add them, I think you can understand that this and this will get cancelled. If you add them, this is plus and this is minus, so they cancel each other out. So I can say this becomes minus b over 2a plus again minus b over 2a, which is nothing but minus 2b over 2a. That is why it is minus b over a. And that's what we wrote, that sum of roots of any quadratic equation is minus b over a. In many of the examples, this can be a very useful formula to remember. So what happens if you multiply? So let's multiply x1 times x2. So let us write it out. So this is minus b over 2a plus square root of b squared minus 4ac over 2a times, this is times, minus b over 2a minus square root of b squared minus 4ac over 2a. Now you can very clearly see a formula here, which is difference of two squares. So this is a plus b and a minus b. So this is nothing but minus b over 2a, the whole squared, minus this whole thing, square root of b squared minus 4ac over 2a the whole squared. I'm doing this so that you understand the formula. You don't need to remember anything. If you remember, it is good, but it's always good to understand before you remember. So this, when you square this, this is b squared over 4a squared. Is it clear? And here what will happen is the square root will go away, so minus, I'll put this in bracket, b squared minus 4ac over 4a squared. So this, when you open, you got the same denominator, so this is b squared minus b squared, you got a minus and a minus will become plus 4ac over 4a squared. So b squared and b squared gets cancelled. So x1 times x2. I'm going to write this 4ac as 4a times c and 4a squared I can write as 4a times a. So this 4a and 4 gets cancelled, so that is c over a. So these are the two formulas that are useful in many of these general type of equation, which can be an excellence question for level 2, and it can be a merit question for level 3. Okay, so let me copy and paste. So these are the two formulas. Let me copy and paste it here. Okay, so we're going to do that again now. So let us paste it here. So we know two formulas. So what they're saying is we know x1 is alpha, and let us say x2 is alpha plus 2. So let us write what is a. A is 2. What is b? B is negative 12. And what is c? C is k plus 2. So what is alpha x1 plus x2? So x1 plus x2 is alpha plus 2. Am I right? Which is 2 alpha plus 2. So this is from the example, but what do we know? X1 plus x2 is minus b over a, which is b is minus 12, so minus b will be 12 over 2, which is 6. So I can relate this and this. I can equate this and this, because this 2 alpha plus 2 is x1 plus x2, and by the formula that we proved, x1 plus x2 is 6. So therefore I can say 2 alpha plus 2 is 6. So 2 alpha is how much? 2 alpha is 4. So alpha is 2. Alpha is 2, which implies your x1 is 2 and your x2 is 4. So you got the roots now. Okay, so here we want to find the value of c. Okay, so what can we do? So what do we know about x1 times x2? So x1 times x2 is 2 times 4, which is 8, and x1 times x2 by the formula we proved is c over a. What is c? C is, we can have this formula. This is c, and this is a. So I can say that is k plus 2 over 2. So again, you can relate this to. Okay, so we are saying two things in two different ways. X1 times x2 is 8, and x1 times x2 is this. So therefore I can say, equating these two, I can say k plus 2 over 2 is equal to 8, which implies k plus 2 is 16, so k should be 14. Okay, so let us go back and check the answer. So what we are saying is k has to be 14, isn't it? Okay, so the equation was 2x squared. What was the equation? 2x squared minus 12x. Let me write the equation. Minus 12x plus k plus 2 is equal to 0. So let me put the value of k here. So this is nothing but 2x squared minus 12x plus 16 is equal to 0. You can factor out the 2. So if you factor out the 2, it is x squared minus 6x plus 8 is equal to 0. So if you divide both sides by 2, this is nothing but x squared minus 6x plus 8 is equal to. Now this is simple quadratic equation, which is x minus 4 times x minus 2 is equal to 0. And we got this, x is equal to 4 and x is equal to 2. Okay, and that's what they are saying. If for this, the two roots are such that one is greater than the other by 2, and that's what we got. So the answer that we got, this is perfectly right.